Hi, I'm Connie.
And I am Adrian, and today we're going to compare means using SPSS features.
Before we start the tutorial, we are going to go over some questions. What are the new features? For this video, we are going to go over a couple of features that we have not gone over in class, and they are the independent samples t-test and the one-way ANOVA method. What software program has these features? The software program that has these features is SPSS. What is the purpose of these features? The purpose of these features is to compare the means of two independent samples. Do any of the other software programs we have covered in class have these similar features? Yes, Excel has both features, but because we are analyzing data, SPSS does a better job at it, which is why we did not choose to use Excel.
In this tutorial, we are going to show the compare means feature, especially for the independent samples t-test and the one-way ANOVA using the statistical software of SPSS. The question for this tutorial is there a difference in job satisfaction between males and females at company X, Y, and Z? The independent variable in which we are dealing with is gender, males and females. The dependent variable that is job satisfaction. We will be using the telecommuting dataset from SPSS. Simply, we will conduct the t-test and the one-way ANOVA from the SPSS file and find out the results. The first one we're going over is the independent samples t-test.
To run the independent samples t-test on SPSS, we first have to go to the toolbar, click on Analyze, go down to Compare Means, and select on Independent Samples t-test. Now we are going to move our dependent variable, which is job satisfaction, into the test variables box, and the independent variable, which is the sex of the employees, into the grouping variable box. Now click on Define Groups and enter 0 in Group 1 for males and 1 in Group 2 for females. Click on Continue and then Paste. Now we are going to name this under t-test. We're going to highlight the whole thing and then generate. Now you can see that there were 204 males and 222 females, with a mean of 3.96 for males and 3.98 for females. And these are their standard deviation respectively. Below here, you can see the t-values, the mean difference, and the upper and lower bounds. But for the sake of this class, we are only going to focus on the values under sig two-tailed. And this is to see if the difference between males and females in job satisfaction at company XYZ is significant. And as you can see, the p-values are 0.780, which is greater than 0.05. This means that there is no significant difference between males and females on job satisfaction. Next, we are going to show you how to create a simple bar graph to help visualize the results.
To do a simple bar graph, first go to the toolbar and click on Graphs. Select Legacy Dialogs and click on Bar. Select the simple one and make sure it is for summaries for groups of cases. Then click Define. Select Other Statistics. Now, move the dependent variable, which is job satisfaction, to the variable box. And the independent variable, which is the sex of the employees, to the category axis box. Next, we want to label our graph, so we're going to click on Titles. And type gender difference in job satisfaction at company XYZ. And click continue. Finally, we're going to click on options. Check display errors bars and standard deviation. And change the standard deviation multiplier to 1. Press continue and click OK. As you can see, the means for both males and females are about the same, showing no significant difference in job satisfaction scores.
Alright, so now we are going to show you how to compare means using one-way ANOVA. For the one-way ANOVA, our question for this tutorial is there a difference in effect among education level on job security? The independent variable is the education level, and the dependent variable is job security. Again, we will be using the telecommuting dataset. Before we start the tutorial, an analysis of variance, also known as ANOVA, is an inferential statistics used when we want to compare mean differences between two or more populations simultaneously. You may ask, why not just run multiple t-tests for that? Well, that is because the more t-tests you run, the higher the probability of an incorrect finding, known as a type 1 error, or in other words, a false positive finding. So before actually conducting the one-way ANOVA, we are going to do a simple means comparison of our independent variable, which is the employee's education level, and how it has an effect on job security. And to do so, we're going to go to our toolbar, click on Analyze, go down to Compare Means, and select Means. Then we are going to move our dependent variable, which is job security, into the dependent list box. And we are going to move our independent variable, which is education level, to the independent list box. Click Paste, and we are going to label this syntax as ANOVA means. Go ahead and generate. And here you can see the means for the effect of education level on job security individually. Now Adrian will show you how to run the one-way ANOVA and show you a graph of all the means.
Now, to better visualize the data, we're going to plot the data onto a graph. To do that, go to the toolbar under Analyze, go down to Compare Means, and select One-Way ANOVA. Then move the dependent variable, which is job security, into the dependent list box. And the independent variable, which is the education level, into the factor box. Click on Options, select Means Plot, and click Continue. From here, click Paste, and we'll go ahead and label this syntax ANOVA means plot. Then finally generate. As you can see from the means plot, you can visualize better how education level can have an effect on job security. But looking at the ANOVA table, the effect is not significant. And we know this because the p-value under the SIG column is 0.536, which is greater than 0.05. Also, to find the effect of each individual education level on job security, we will have to do a post hoc test. However, for the sake of this class, we are not going to do that. On that note, this concludes our tutorial on how to compare means using the independent samples t-test and the one-way ANOVA. Thank you so much for watching.